All right, welcome to the first day of capstone project presentations for our second fall term 2023. We have a mix of 596A and 596B presentations tonight. I'm Jim Detweiler, the faculty lead for the Geospatial Programming Certificate. For those who don't know me, I'll be the MC for tonight. We have 5 presentations on tonight's docket, 3 of them being 596B and 2 596A. Before we get to them, first, a few reminders. Presenters, you're going to have 25 minutes to give your talk, followed by 5 minutes of questions. Audience members, if you have a question for a presenter, please enter it into the chat box. You might consider holding off on sending your question through the chat until the presenter wraps up so you don't distract them during their talk. Presenters, please read the questions out loud so that anyone watching the recording will know what you're responding to. The chat box is not included in the recording. For the 596A students, we are expecting you to provide each speaker with some constructive feedback. Others who are attending are invited to do so also, and I will post a link to the peer review form in the chat box. Presenters, when you're done, please share your email address through the chat box in case anybody has any follow-up questions. With that, let's get started with our first presenter, Nick Murray, who is doing a 596B presentation. Nick, are you ready to go?
I am. Can you hear me? All right.
I can hear you, yes.
All right. Right now I have disabled screen sharing at the moment.
All right, let me see if I can fix that. All right, give it a try now.
All right, it's working. All right, can everyone see that my screen sharing is working properly?
Yep, I can see your slides, so take it away.
All right. Well, good evening, everyone, and thank you for your time and schedule we've all set aside for these presentations, and I look forward to starting off our 5 presentations. I am presenting 596B, and my presentation is proximity analysis on income inequality and fossil fuel power generation in Pennsylvania. And my advisor is Panos. The goal of this project was to locate income census, low-income classifications for census tracts distributed amongst urban counties in Pennsylvania, and locate industrial sites affiliated with power generation in proximity. I sought to evaluate potential trends and any significant correlations in the proximity of low-income classified census tracts and electricity generation facilities that are in proximity. The end goal was to run generalized logistic regression off of the low-income classification per census tract and calculating a near distance between each census tract to see if the logistic regression would show any significant results. As a background, air pollution is known to adversely affect human health, and air emissions are an inherent byproduct of the combustion process. I ended up honing down to electricity generation facilities that are denoted to use fossil fuels in the generation process, and the primary majority are coal-powered power plants. Combustion emissions have been proven to be responsible for a significant amount of premature mortalities, and the proximity where the adverse impacts can be distributed to at least 30 miles from each coal-powered power plant. For the data I was able to gather on census tracts and low-income classification, I resulted to the economic justice screening tool from the Council of Environmental Justice. This utilized American Community Survey income data by household median per census tract across the entire United States. They also included a low-income classification that was designated as 200% or below of the federal poverty level. For power generation facilities, I was able to use the Environmental Protection Agency's electric power generation e-grid with a distribution of all recorded electric power generation facilities and the source of their power generation. I targeted fossil fuel powered facilities and filtered out renewable energy sources, specifically solar, hydro, and wind. In terms of the specific study area in the counties of Pennsylvania, I honed in on Philadelphia, Allegheny, and Dauphin County as the capital of the state and the two populated urban counties in housing Philadelphia and Pittsburgh. I filtered out industry sites outside of 20 miles from the county per county to attempt to withhold a significant amount of industry sites while not extending out to the 30-mile radius that I gathered in my background information. I came with a total of 939 census tracts, and 343 of those met the low income classification. The low income classified census tracts are shown in red, and the final count of industry sites for this study are shown as the stars. I ended up with 70 industry sites between the three counties. I put together a distribution of the population and the low income to total census tracts per county and the industry sites that were within 20 miles of any census tract per county. The highest population county and county with the most low income census tracts is Philadelphia County. An important note that the low income classification for this study is universal between the three counties and did not take into account local cost of living. To prepare reaching the final methodology, I used the featured point tool for each census tract to get a centroid point object per census tract. This was important because some power generation facilities are located within census tracts, and a near distance for these census tracts would be calculated as 0 and would conflict with the type of analysis being performed. Once each census tract had a centroid point feature, I was able to run a near analysis to create a near distance between each census tract's center and the nearest industry site. This is in meters and will come up as something important in the results. I used a binary model for generalized logistic regression off of a binary classification of whether or not the census tract was classified as low income, with 0 being not low income and 1 being low income. After running the analysis and getting the results together. The main results of the logistic regression are as follows. Both p-values were considered significant for my variables. And while the coefficient of the closest industry site is apparently less significant, that does represent a coefficient per meter, and the median distance per census tract is in several kilometers. I have some of the remaining graphs of the logistic regression to follow, but I wanted to start with any questions moving forward on any of the results thus far, or any of the decision making or data used to go through with this regression.
Looks like you do have a question from Ryan.
I performed all of the data preparation, manipulation, and the regression in ArcGIS Pro with the binary model for generalized logistic regression. The low income classification is shown on the right as the FPL 200S value of 1, and it shows in detail in meters some of the distribution of all 939 census tracts per classification. I ended up recording the confusion matrix in the following slide, and the model showed a prediction performance of approximately 63% in correct predictions for the census tract income classifications. I felt that income and household income through varying urban counties and different costs of livings is difficult to navigate while reaching a significant amount of data for a model like this to be statistically significant. And I felt that it's an expansive topic, but I was happy reaching, the end of going through the data and setting up this presentation and going through some of the results with my advisor and now my peers.
Okay, looks like you have another question in the chat.
The distance calculation was crow flies. It is a straight distance, and I felt that this was a better suit when taking into account air emissions and general proximity outside of how long it would take through a cost distance for driving. Thank you for asking that, Matt.
Okay, other questions for Nick?
Did you consider looking at data over a longer period of time to see how your results would vary over time? when I took into account a time lapse and taking in data from multiple years or decades, I was worried that the industry sighting was generally pretty prevalently consistent, due to some of the counties, mainly Philadelphia County, um, at the time when these facilities were constructed or at least classified, and that the, well, to be honest, the income classification wouldn't, and I felt wouldn't be consistent to maintain the same classification for the census tracts as low income. The confidence of using the American Community Survey, at the same, at least collecting that data through the same source of income recording at the same percentage of error, and that I felt that I had gathered enough at present to run this analysis given a single time frame. Are there any other census variables that might be useful to explore in the same way to see if they are related to energy production? There are, especially with that tool. The first one that came to mind is obviously air pollution and median PM 2.5, particulate matter, quality. I would say asthma rates in proximity to, specifically coking plants, coal powered power plants. Specifically, well, in terms of census variables, I would definitely say, health or asthma related rates, particularly now, in youth or childhood asthma related events or emergency asthma related events, and look at those variables, in proximity to how many sites are in proximity. It's another thing that I tried to fit into this project was one census tract might have close proximity, but it's only to one plant in, say, 15 miles, and another census tract may have been charted not, let's say, middle of the pack or kind of farther out across the median proximity to an industry site, but they might have 10, such as in certain census tracts in Philadelphia. They might have more power generation facilities, not necessarily as close as others, but they have a higher concentration around them, and maybe 6 to 10. So
other questions for Nick? I guess I have one. Nick, if you were in an elevator with someone and happened to strike up a conversation and mentioned that you just finished up a master's degree, what would you tell this person was the findings of your project?
I would say that I look to see any statistically significant correlations between the proximity from census tracts to the nearest fossil fuel coal power plant, and see if this generalized logistic regression model produced results that showed that I could predict whether or not that census tract was low income, whether or not there was any predictors or really any significance here that there's a concentration of lower income communities in proximity to, these power plants and these industry sites that, is there something here in this model, that I chose to run? I would say that off of just the project alone, I wasn't in a position to say, yes or no, and it's probably a larger picture in terms of variables and running more projects and planning on this. But I felt that it was also in a second part, you becoming proficient in using, the GIS software to run this procedure, when others certainly have run it in the past without utilizing GIS in this way. And I felt that that was one of the main points, was that I wanted to locate this data and run this procedure within ArcGIS Pro and utilizing GIS to come up with this analysis.
Okay, good. Other questions for Nick? All right. Well, thanks, Nick, for making your presentation. Congratulations on finishing. Let's move on now to Crystal Perry, who is also a 596B presenter. She's going to talk to us about well site location in South Africa. Are you ready, Crystal?
Yep. Can you see my slide?
Not yet. I can hear you.
Let's see what's going on. Do you see it now?
Yes, we can.
Okay. My projects will be a GIS approach to finding sites for wells in South Africa, as mentioned. The image on this slide are the 9 provinces within South Africa. First I want to go over background. So Africa is considered a water scarce country. Water scarcity is when the demand for water exceeds supply and available water resources are approaching or exceeding sustainable limits. This country has both a failing infrastructure and increasing population. This has led to overcrowding of communal taps, dangerous boreholing, and unsafe acceptance of contaminated groundwater sources. In my study area in South Africa, it is interesting in that this area has wells that are full of water and is still considered a water scarce country. This is due to the fact that the infrastructure in South Africa is below average when compared to countries such as Nigeria and Zambia. The quality of the infrastructure and poor management of the infrastructure in this area has led to poor and decaying wells in this area. So this slide shows the physical and economic water scarcity in Africa. 2 terms I would like to go over are physical water scarcity, which is when the demand of the population exceeds the available resources of the region. This could be from severe environmental degradation, declining groundwater, and water allocations that favor some groups over others. And economic water scarcity is when there is an adequate water supply, but there is a lack of available water from a lack of water investments, such as in water infrastructures. This map shows what was reported by the United Nations in 2011. In North Africa, this is considered an arid region, and the water scarcity is related to physical water scarcity. Sub-Saharan region has economic water scarcity, and in my region, there's a good physical water, but it is constrained to poor infrastructures. This slide shows some consequences of water scarcity. The first bullet is agriculture. This is very important in that agriculture accounts for 14% of the total gross domestic product in Africa. Agriculture is heavily reliant on water. It can also affect health issues. If the area is water scarce, you will find water in any means possible. And this may mean getting water from contaminated areas such as ponds and streams. This can bring on diseases. This can be a dangerous thing for Africans in that the quality of healthcare is low and only 48% of Africans have any access to healthcare. Water scarcity can also lead to food insecurity, and that 70% of fresh water withdrawals go into agriculture. Eventually, water scarcity can lead to human conflicts. This slide goes over groundwater versus surface water. Groundwater is water that exists underground and in saturated zones beneath the land surface. The groundwater fills the pores and fractures in underground materials such as sand, gravel, and other rocks. The layer of water bearing permeable rock fractures are the aquifers. Groundwater can be cleaner than surface water in that is underground and not collecting contaminants. However, that does not mean that it is uncontaminated. It can be contaminated, for instance, with fertilizers by farmlands. Groundwater can be affected by porosity, permeability, transmissivity, and recharge. Porosity is related to the gaps in the grains of the rocks. When there is a lot of gaps in rock, it will have a high porosity and be able to hold more water. Permeability relates to how water moves through the rock. Good permeability, therefore, means the water is able to move through the rock. Transmissivity is the rate at which water can flow through an aquifer. Recharge is when water seeps into the ground to replenish groundwater aquifers. I will go over this more when I discuss soils later on. Lastly, groundwater is accessible during periods of droughts. Now with surface water. It is the water above the ground that forms terrestrial water bodies. Surface water can be more contaminant than groundwater can, and it can become contaminated from numerous things such as sewage, accidental or deliberate spills, erosion, or runoff. Surface water will need to be treated to be safe for human consumption. This is an overview slide of my problem set. As a reminder, South Africa is a water scarce location due to poor well infrastructures. For my study, I found groundwater potential areas in South Africa. Then I created a groundwater potential map for these areas. Then I created a second map to subtract areas that could be contaminated to wells, such as near farmlands, to give me an area of potential areas for wells. This slide shows the methodology of approach that I took during my study. First, I used a GIS-based multi-criteria decision approach. This type of method helps to determine the best alternative by considering more than one criteria in the process. I had several criteria for my analysis, such as drainage density, slope, lineament density, land use, land cover, soil types, geology, and rainfall. This type of method aims in the decision making, such as where are the areas of groundwater potential. Each of the criteria was created in a rasterized map with a scale of 1 to 5, low to high potential of groundwater. I then used the AHP method analytical hierarchy process to organize and analyze my decision. The AHP method is a pairwise comparison method that is used for applying weights for all of my classified raster maps from my criteria into one groundwater potential map. This is just an overview of what MCDM is that I just went over. It's a way to structure my data to make better informed decisions. I apply weights. Each of my criteria maps from 1 to 5, from low to high for groundwater potential. The next slides will go over my criteria maps and the process. With the maps as discussed, I will reclass all maps from 1 to 5, from low to high. This will help later on in the process when I create the final maps. So the first map I will go over for my creator will be drainage density. Drainage density is the total length of the channels in a watershed that's divided by the total area of the drainage watershed. When viewing a drainage density map, the higher the drainage density correlates to a lower probability to groundwater potential. The created map shows areas of very low to very high drainage density. This map was created using the Strahler method and the hydrology tool in ArcGIS Pro. This method uses a hierarchy of streams from top to bottom. It essentially joins streams of the same order. The image on the slide shows an example of how it works. Stream order 1 are the uppermost channels to the first confluence, or the point where the streams meet to become the river. The second order is below The first two order streams and the third order stream is the joining of the two second order streams. Knowing the stream order can give you clues into the size and depth of the channels. So here's the actual raster map that I came up with. The darker color, blue, was the higher drainage density. This correlates to the higher the drainage density, the lower probability of the groundwater potential. Now the alignment density. Alignment density are fractures or faults in the surface. Lineaments have an increased permeability and porosity. The alignment map will help with the classifying understanding of the surface water and the associated faults. I created this map by creating hill shades in ArcGIS Pro using the dim layer. 4 different hill shades was created with different azimuths for this purpose to display and ensure all alignments are captured from the dim layer. The azimuth is the angular direction of the sun. The degree starts from the north and moves in a clockwise direction back to north from 0 to 360 south. The default is 315 degrees northwest and 90 degrees east. After the hill shades were created, a shapefile was created using polyline to lines to show the alignments. Then the line density tool in ArcGIS was used to create the alignment density map. Now for my slope map, the slope can be defined as the steepness of the ground surface. The slope is measured from the rise over run. The rise is known as the increase in elevation. The run is the horizontal distance. The slope was created by the SRTM DIM, and I used the slope tool in ArcGIS. The SRTM was downloaded from the NASA Earth data, and it was a 30-meter resolution. On the left is my alignment density map. The darker the color, the higher the alignment density. So the higher probability for groundwater, the darker the color. The map on the right is my slope map that I came up with. The map was reclassed to 1 to 5 in terms of groundwater potential. So the flatter the terrain, the higher the rating for the slope. This is another raster that I had to use. This is a South African National Land Cover raster, but I reclassed it into 5 classes using water bodies, vegetation, built up areas, agriculture, and bare lands. This helped when applying weights and reclassing 1 to 5 for groundwater potential. For example, a higher weight was used for water bodies and a lower weight was used for bare lands. Now my soil type map. The soil type affects the water recharge and water holding capacity of the area in terms of groundwater. The larger the surface of the soil, the more it is able to retain water and therefore will have a greater capacity to retain the water. For instance, sandy soil with coarse particles will retain less water than clay, which has smaller soil particles. Later on in the process, soil type was classed by how effective the soil type is able to hold onto the water. For example, the clay was ranked higher than sand. I have downloaded the data from the ISRIC World Soil Information for Africa, and the image on this slide shows examples of how different soils affect the available of water. Here's my soil map. I reclassed to the main components for the soil. So I use sand, loam, silt, and clay to the best of my abilities. Next is the geological map and rainfall map. The geological map was downloaded from the ISRI portal. And I tried to reclass these to carbonate, non-carbonate, karst, metas, sedimentary, and water. They were then reclassed to more or less permeability, or what allows liquids and gases to pass through. My last map, made in class prior to my AHP process, is a rainfall map. This map was created from the NASA Global Data Assimilation System, and it is from 2016 to present and shows the annual rainfall. The higher average of annual rainfall received the highest classification of 5, and the lower average of rainfall received the classification of 1. So here's my geological map and my annual rainfall map. Now that all my criteria raster maps were created in class from 1 to 5, I performed the AHP process, which is what you're seeing now. As discussed, this is a pairwise comparison method using criteria weighting. Essentially, I am trying to figure out mathematically for GIS how much each criteria is weighted as a percentage of the whole of the map. I use this Excel spreadsheet that was created by Klaus Giapel to help with my calculations. That is what you see in this slide. I then entered all of my criteria in the blue part that you see on the top left. Below that, I compared each of the criteria one at a time to each other. For instance, if the column A or column B is more important. So for my example on drainage, you can see if the first line I am comparing, it says line density. I had an input of A for column A because I felt like drainage density is more important for groundwater than lineament density. In the column next to it, you input a scale of 1 to 9, 1 being that the pair is equally important and 9 is extreme importance of one criteria over the other. The Excel sheet was then automatically places it into a matrix vector and the weight is calculated. It then will tell me the consistency ratio of 0.1 to 10% is reasonable. And then if it's greater than 10%, it means you have an inconsistent judgment and my pairwise should be adjusted. For my final CR, I obtained a final score of 5%. So it told me my final results were of sound judgment and I could move on to the next steps of my process. I actually had to do this a couple times. I think the first time I had 11%, so I did not have good judgment, but my final results was 5% that I used. Now that my Excel calculations are completed, my thematic maps are completed and classes with 5 classes, I then went back to ArcGIS to create my final groundwater probability map. I used a weighted overlay tool to apply my weights. I then used the Excel sheet to enter the percentage into the tool in ArcGIS for each of the maps. This is the percentage of influence for the calculations of the sum of influence equal to 100% upon completion of the tool. I then use an evaluation of 1 to 5, same as the other maps, low to high probability, ensure that my ranks were appropriate for each criteria. An example, if looking at the alignment tool and within the tool, I entered a high alignment density as a high rank, then the least alignment density as a lower rank for that map. For slope, the less of the slope, the higher the rank. This is due to the chance of runoff with a higher slope. After running that tool and the map was created, I then added a field to the table and calculated the areas. Oops. And then that gave me a final groundwater potential map from poor to excellent. And what was interesting is I only had 2 areas that had high potential. These 2 areas were listed on the left. I'm not for sure how to pronounce those, but they're listed on the left. And then I used the Natel one to remove any contaminations from my project for my well site. So the contamination areas that I removed was 25 feet away from roadways, 20 feet away from water source such as rivers, 50 feet away from agriculture, and 15 feet away from property lines. And then you can see the difference between the areas. And that is it. Pending any questions.
Okay, thank you, Crystal. Good job. Do we have questions for Crystal? While we wait, I have a couple. I'll start with one. I might have missed this, but was there earlier work on this topic that guided you in terms of the the different layers that you constructed to be part of your weighted overlay analysis?
I did a lot of research on what contains a good well site. So yeah. So I found out like what contaminated, what it needed to be, if that makes sense. So that's where I got all my contamination areas from. And then also how I use my weights. There's a lot of research into that.
Okay, good. Looks like you've got a couple in the chat box now.
I'm not sure. So that was weird. Yeah, I only ended up with 2 locations. What was very interesting for the excellent well groundwater potential areas for all of South Africa was those were the only 2 that came up using my criterias. And did you consider applying this method to another geological locations as a way to I did not run the method through. You're talking about running it through like another area? Yeah. I just played with the weighting to make sure, but I didn't actually run all the results through a different area. But I did play with like my weighting and to see if it would work.
I had a follow-up question. I noticed on the AHP slide in which you did your ratings of the various criteria, that along the top there was a participant number, which implies that you're asking multiple people to weigh in. No pun intended. So did you talk to anybody else about this? Perhaps a expert in water quality, water issues?
The participant number was not really used. That was more like how many criteria. Let me see if I can go back. You're talking about right here?
Yeah.
Yeah, that really wasn't used a whole lot. I looked at a couple researches, not wells, but I did see a couple researches with AHP methods. And that's how I came up with the AHP method for my process, I guess.
Okay. The weighted overlay tool, is that well, if you were to modify your ratings, change them around, how easy or hard would it be to rerun your analysis?
That would be actually really easy. So you would just open up the weighted overlay tool and just pretty much change the percentage and rerun it.
Okay, good.
Yep.
Any other questions for Crystal? Looks like Fritz is just suggesting that it's a good idea to bring multiple people in to, try to come up with a consensus. So that's something to consider doing this again going forward.
As in the criteria you're talking about?
Yeah, just because it's there's a lot of subjectivity involved, and it's always good to
I
bring
could
in.
see that because see where the CR, I got 5% from my final. Well, that wasn't what I started with. I actually got like 11% that tells me that my judgment was off at the beginning. So it could be
Okay.
where if you're talking to more than one person, maybe you can combine thoughts, processes, things like that.
Yeah, that's the kind of thing that I've seen on this kind of topic before, where you're weighting multiple criteria. It's always considered a good idea to bring in as many expert opinions as you can when you're dealing with subjective decision making like this. So, but nice job. Any other questions? All right. Well, thank you, Crystal. Good work. Congrats on finishing. And
Thank
that
you.
brings us to our next one, Fred Halwerda, who's going to be our first 596A presentation tonight. Fred, are you ready?
Yes, sir, I am.
All right, I can hear you.
Okay, I am pulling up my screen now. Hopefully.
All right, looks good.
There we go. Okay. Excellent. And Crystal, I'll say thank you for introducing the analytical hierarchy process. It's something that I'm working on as well. And you'll notice later on in the slideshow that we have a similar, we have Klaus's Excel document. It's the same document. Mine's a little less refined than yours, but I do appreciate your succinct clarification of what AHP is. So that'll save me a few minutes at least. Okay, so good evening, everybody. Like Jim said, I'm Fred Halwerda. I'm a 596A student, and I'll be talking to everybody tonight about the airbase site selection with the support of geospatial artificial intelligence and the analytical hierarchy process. A little bit of background about myself. I am a combat engineer in the Marine Corps, and my job a lot of times is to build air bases or bases of any type, but air base is pretty common. And as we build air bases, there's a lot of different things that we have to go into as far as considerations and parameters. And really using geospatial AI and the analytical hierarchy process is something that can help us build this process or build an airbase and make it faster than the traditional process. So with that, just a quick agenda for tonight. I think you're all familiar with this. We're going to start with the background, our goals and objectives, our methodology, timeline, and finally our results. So the background on the project, like I said, I'm a combat engineer and I build airfields a lot of times, but the process of building a site survey is the initial step of building an entire airfield or air base. That process takes a lot of Marines, a lot of manpower, and you're typically found running around on airfields with a Trimble system where you have a guy with a surveying equipment on one end of the airfield and another guy running around with a meter stick or a GPS receiver on the other end. So it takes a lot of time, and it's very difficult to do this in restricted or non-permissive environments where we can't be there right now. We have to do this in a remotely sensed setting in order to not really show our hand that we want to be there. And other times we want to speed this method up because there is a crisis management situation like earthquakes, tsunamis, or hurricanes that can cause severe damage to infrastructure and civilian population emergency management situations. What the Marine Corps can do is do a remotely sensed product of some sort and alleviate the traditional survey method. That means we're on a boat going towards that place and we can do some sort of site survey from the boat rather than having to put boots on the ground to figure out what's going on. So really it's a process of getting a site survey done of the airfield or of a potential airfield. So just an empty field or empty site in which we can build a site survey. Next, experience is difficult to keep at the ranks that do this type of job. So typically it's a lower officer or a senior enlisted member who does this job, but it's kind of a middle job. It's a middle management position that doesn't always stay filled for more than a couple of years. So that experience is constantly moving up in the ranks, and it's difficult for a new person like me when I did it to learn how to do this on the fly. And lastly, it's difficult to do a site survey that fails to account for variables and priorities that change. And that's where the AHP process, like Crystal talked about, comes in. And then we'll talk about the decision-making process as well, or multi-criteria decision-making process as well. And lastly, there's no readily available application in the DoD arsenal that does this for us. Really, we're just kind of winging it with PowerPoint and Excel and hoping that our calculations are right and that the YouTube video we watched gave enough information to be able to produce results that we need. Sometimes it's a little scary, the amount of, or lack thereof, of training that we have to do in order to bring in aircraft. But in the end, usually it always works. And there are guys with experience who are able to step in and pull red flags when needed. So in order to alleviate that problem of it not being in the system, I would like to develop some sort of application that can do this for us and make a lot of these decisions and eliminating the reliance on experience throughout the process of doing a site survey. So the background and my literature review talks about the analytical hierarchy process, which is critical to the multi-criteria decision-making concept. And a multi-criteria decision-making concept can be any decision-making process that has many, many decisions that can influence one another. But also what I don't want to do is eliminate certain criteria, either this or that. It needs to be this and maybe some of that to make our decision or make our final product. Which leads us into the multi-attribute utility theory, or MOUT, which gives some utility or weight to every criteria within the decision-making process. And this is the weighting that Crystal talked about as well, but there's weights assigned to each variable that then later on are accounted for when building maps and building geospatial products, where certain decisions are not eliminated or certain outcomes are not eliminated based on whether or not one parameter is selected or another parameter is selected. So the AHP process can be program oriented, which means it can be done through like a software type program, or it can be done in Microsoft Excel, which I understand is a software program, but it's a little less complicated than maybe a full application. Next, for my literature review, I did some geospatial artificial intelligence analysis, just learning about how some of these programs can either enhance or improve planning in a professional setting, especially in construction where you have large construction sites where assets and resources need to flow through the construction site. When they're finished being used at one location, they can start at another location rather than letting them sit and be stagnant. We can flow resources with geospatial AI forward in the construction project. So for air-based planning, we can always move bulldozers or cranes or welders. A number of different things can move around the airfield at the same time. Other processes are getting started in order to facilitate a faster construction time. Next, LiDAR can enhance GeoAI's accuracy through point cloud data. At this time, and for my project, I chose not to use LiDAR because it's a limited resource and I don't have full access to a good data set where I can use it. But the accuracy for LiDAR is significantly better than a 30-meter spatial resolution is what I used. So in using LiDAR, it's basically the next step after this proposal is to look at how LiDAR might be able to be intertwined into GeoAI's accuracy. And then lastly, geospatial AI is very good at detecting airfield and airport obstacles. And I'll show just a brief synopsis on the slide. This again is another step in the final direction where geospatial AI can look at an airfield and determine what might or might not be an obstacle to aircraft ingressing or egressing from an airport. So looking at the background for the multi-criteria decision-making process, here are the multi-criterias that we have to look at. And I don't expect you guys to be able to see these or read these, down to the nugget or anything like that. But there's 76 different options on this page. And all of these options are really anything below the first level, that first 5. Everything below that is something we're going to discuss in a Marine Corps planning process right away. I mean, within the first hour or two of the commander deciding to execute an airbase style mission, we're going to have a conversation one way or another about all of these different things. And this is just the first step. But all these things can also change the way an airbase is laid out. And ultimately, how that airbase is laid out depends upon that site survey. And that's how critical the site survey is to airbase design. Because if the site survey isn't done properly the first time, you're fighting your plan and you're not fighting the crisis or an adversary, you're fighting yourselves at that point, which is not really conducive to moving forward in the process. But this just gives a picture of how many decisions are made within just the first few hours of planning. So the goals and objectives of my research project is how can a geospatial information system application reduce the cognitive burden of our decision makers during airbase site surveys and develop an airbase master plan. So the site survey is step 1, and we'll say the master plan is step 10, the final product. So how can I reduce the cognitive burden between getting that first site survey done all the way through the final plan? Because once the site survey is done and you know what you're looking at, everything else really falls into place and becomes an airbase master plan. And you can keep building past level 10 if you want to. But at that point, we're talking about trim and headboards and all kinds of fancy stuff. But really, to get an operational airfield is just the airbase master plan. The goals for this plan, what I want to look at is to be able to provide airbase planners a means of remotely identifying a suitable airbase location based on our aspect, slope, and azimuth of the land that we're looking at. And I'll go into that in just a sec. Next, we want to provide our airbase planners with our weighted priorities that adjust as mission variables and parameters adjust. So a commander can come in and change his plan at any time and change variables and priorities at any time. So we have to be able to adjust for that. And I'd like to have some sort of application that can do that. And then lastly is developing our software application that combines everything that I just talked about, our GIS data with our variables, and generate a model for our prospective airbase, and therefore develop an airbase master plan for us. So our proposed methodology, just moving into how I plan to work this, is I've got a study area of Camp Lejeune, North Carolina. Pretty simple for me. It's where I was trained as a combat engineer. All combat engineers go through there. And I'm pretty familiar with that area. There's 2 major developed airports in the area. One is the Albert Ellis Airport. That's suitable for Boeing 747s, which is one of the larger twin engine aircraft that we could land any type of really military aircraft at that type of airfield. And then secondly, there's the Marine Corps Air Station, or MCAS New River. And that's basically just helicopters is at that base, and the Osprey aircraft, so vertical takeoff and landing. But the reason why I selected this area is because those 2 airports should show up as like controls for my study. And I'll show that later on what we're actually looking at when we go into slope, aspect, azimuth, and so on. And then one of the other reasons I chose this area is because it's primarily rural and coastal plains, meaning it's mostly flat. It is wooded, but mostly flat, sandy areas where most of the map should be suitable for an airfield. It's just the way the land lies is the important part. And that's what I want to look at because the way the land lies and earthwork takes a lot of an airbase site survey planning. So if you can't use an airfield that's already established, you have to do a lot of earthwork in order to make that airfield suitable and make the site survey suitable for the airbase master plan. So the proposed methodology here, just going into the methods that would be repeatable. We got to retrieve data from the U.S. Geological Survey's NED, National Elevation Data Set, which is a DIM file that comes in TIFF format. It's a 30-meter spatial resolution. Next is we got to create TINs of both, we got to create TINs in ArcGIS Pro and remove unsuitable TINs from the data set. So there are some in here where it will show ocean, rivers, and marshlands, and we know that we can't put aircraft on that, and it would take too much time to stabilize that type of area. So I eliminate those from the process and from the analysis. Next, we need to designate TINs that have suitable east to west aspects, which are suitable to aircraft prevailing winds in the northern hemisphere. After that, we will create a slope analysis of the TINs that designates the suitable slope. And most military aircraft need less than 5% slope over a given stretch of land. So we'll designate those areas in just a moment. I'll show a figure that has some of these analysis work on it. And then lastly, just some of the housekeeping stuff is transforming TINs into the UTM format, which is the military grid reference system. And then we'll extract some of the intersections for suitable aspect and slope to locate our ideal airbase site for our site survey. So on the left of the figure 3, we have our TINs with east to west aspect ratios near Camp Lejeune. And here we do see some of the TINs located in the ocean. So on figure 4, I appended those TINs and removed those and selected just the TINs that have, or highlighted just the TINs that are suitable with a azimuth of northeast, east, southeast, or southwest, west, and northwest. And that's the colored TINs that you see on the screen. Next, we apply our slope aspect. And in this case, there's one very large TIN that showed up. There are numerous small ones on this map as well. But this one, I know personally, I've been to this one before. This is a backstop for range for gun shooting. And it catches bullets. That's its job. So it's an engineered slope area on Camp Lejeune. But what it tells me is that we have an ideal airbase location based on aspect and slope for a runway in this location. So at least the idea and the methodology worked in this instance. And now for the smaller ones, for the smaller TINs that did show up as well, those would be suitable for more VTOL or vertical takeoff and landing type aircraft, such as helicopters. But I also think there's a chance that we could merge TINs together to become a larger runway that would allow for fixed wing to land on those as well. So just a continuation of our research methods. So after we've developed our map, we have to apply the AHP process that evaluates variable importance. Next, I want to develop a geospatial AI that automatically does everything that I just described with the weighted variables and the DIM, along with the TINs that we came up with and the intersection points, in order to create a final site selection that is suitable based on my experience and what I understand to be feasible from the military kind of mindset that I have. And lastly, we'll model the airbase site selection for decision makers and planners to use. So the analytical hierarchy process and is listed here. So we just saw this. This is made by Klaus. As Crystal mentioned as well, we used, I think, the same format. I entered my criterion here on the A perspective or the A window, and then they automatically populated into the B window for me. And my issue is, and the reason why I said mine is a little less refined, is my consistency ratio is very high. And you'll see that as the 55% on the B window. But what I did find is that aspect, slope, and area are also what I ranked as very important in this instance in my methodology. There are a number of different other things, and as Jim mentioned, I could put more participants in this, and I did some from the logistics officer standpoint. I try to do it from the fuels officer standpoint and maybe a pilot standpoint as well. But then I just found my consistency ratio went through the roof. It was upwards in the 80% range, because depending on your outlook of importance, a lot of these things are going to change. So from the engineer mindset, this is what I was able to come up with. And it seemed suitable for me, the aspect, slope, and area. And it seems repeatable at least, but it is something that I may need to refine as far as my scale numbers, where the arrows are pointing, to really hash out what is important and what might be less important than what I ranked it as. So in my methodology, I just used a flow chart from, I believe it was 586, one of our intelligence analysis classes. Can you still hear me?
Yeah, I can hear you now. You dropped
Okay.
out for 10 seconds there.
Okay, I'm sorry. Something just beeped in my headset. There we go. Okay, so as I said, this is from an adapted framework for classical research. I believe it was 586 at Penn State. And really it's just gathering the data, then summarizing our data, analyzing and interpreting our data, understanding and generated knowledge from our data, and then sharing our data. And there's the key word in all of this is refinement. So here's my project timeline in December. So we're presenting right now. By January, I'd like to test this analytical hierarchy process and GeoAI. In Camp Lejeune, I can actually go there physically. I have a trip planned for a work meeting, but I can go physically visit some of these other areas and see if they are suitable. And the same thing is true for February. I have different trips planned where I can go walk the ground, but ideally I could take this some other place, my application idea, run the TIN methodology that I described, saying like Charleston, South Carolina is another trip that I have planned, and attempt to run it there and then walk the ground there and see if that was suitable. And if it is, it might deem that my idea might work out. And then by March and April, I'd like to present my findings at a number of conferences is what I've found. So there's a defense remote sensing or commercial sensing event that I plan to go to, then a reconnaissance and surveillance conference, and then modern day marine is kind of my catch-all. It's a conference based on future Marine Corps ideas that I think might suit what this project is attempting to fulfill, like the gaps that I'm trying to fulfill. And then lastly, just finalize this product for real world implementation. So my anticipated results for this project, this is going to be a software program or application that reduces the cognitive burden on air-based planners. And then it's a revolutionary application that prevents planners from restarting air-based development in the event of changing variable priorities, crisis situation changes. We decide that we can't land in a certain location and have to change, physical, geographic location. We can start planning as soon as that order is given, rather than waiting until we have GPS data in order to do so. As I described earlier, GeoAI can look at obstacle analysis. This is on the right at figure 9 here, is a geoanalysis of San Francisco airport's obstacles. So why I brought this in is because this is one of those threads that I've just been describing throughout the whole thing. Is another one of the threads that is already in ArcGIS, but is not fully used yet, that are fully tied into how the Department of Defense can use it to build an airbase planning or site survey application. What I'm trying to say is basically the threads exist, the fabric isn't there yet. And what I'd like to do is tie these threads together so that way guys who come into the Marine Corps after me and have to do airbase planning are able to do that without having to take all the hard learning steps that I had to learn as well. They can simply click through a few buttons, rank their priorities, and then get an answer rather than stand out on an airfield with a GPS receiver and a number of different Marines. So ultimately, that's what I'd like to do. And with that, are there any questions?
All right, thank you, Fred. Nicely done.
Thank you.
While we wait, I'll just remind everyone, especially you 596A students that are in attendance, please give some feedback to Fred through the peer review form that I posted the link to in the chat box. And with that, it looks like you do have a couple questions.
Okay. All right. From Fritz, will your workflow eventually be used for airbase site locations outside the US? And what considerations would you need to acknowledge moving to other locations? Perhaps including soil conditions. Okay, so to answer your first question, ideally, yes. I would like to use this outside of the US. And this would be used in crisis response situations and additional considerations that we would need. The most important thing I think we would need is either the synthetic aperture radar or some type of radar to do to do a slope analysis from a UAV or potentially from a manned aircraft, one or the other, in order to get the lay of the land and to get like a real-time lay of the land to begin planning. I think is what we would need before we would need to move to other locations. Definitely the soil conditions is a big one. That is something that I talked with Dr. Thomas about, potentially doing a land classification analysis, because there's a huge portion of time that is attributed to clearing, grubbing, and stripping, which means if there's a forest in an area that's perfectly flat, there's still a lot of work to be done. And maybe we'd have to eliminate that area. But if the ground is all sand, that's a whole nother story because sand needs to be stabilized, mud needs to be stabilized. But yes, so Fritz, I think those questions are perfectly valid and definitely are considerations that I need to look into as well in building out this proposal. And from Matt, I have seen land use planners do something similar at the city government level. Have you considered using ArcGIS GeoPlanner? I have not yet. Matt, I am looking, I've been through QGIS. I tried to do this in R, and then I'm working on getting access to Microsoft, and I think it's Azure, I want to say. But their version of, I think it's Google Earth Pro. I've been attempting to learn that basically through YouTube and through some other steps. But ArcGIS GeoPlanner I have not looked at yet, so I'll take that down right now. Thank you, Matt. Okay, and from Crystal, it looks like more. Is that it's just a suggestion?
Yeah, it's just a suggestion. That's what
Okay.
helped with me.
Oh, yes. And I see what you're saying. When it's high, saying your judgments are off throughout the Excel. Yes. So in going through, let's
So
see.
just change those, see those numbers? So
Yeah,
when
I
you're
don't,
going through that, if you start mess with it, you'll see it change a little bit.
yes.
Because you want to get under that, within that CR percentage to make your judgments correct.
Okay, to really uniform these scale numbers is what you're saying?
Correct, yeah.
Okay, yep, definitely. Yeah, and that's what I was saying. I think when I went through this, I started off solid and then I kind of fell off. I think I did it too many times trying to be the logistics officer, the fuels guy, the admin guy, all the other different weird little hats you can put on as a everybody who has a planner in this would have an option and would be one of these participants, I think. But yes, I see what you're saying there. Thank you. Okay.
Fred, am I understanding that the end product or an end product of your work would be a custom tool that your colleagues would be able to open up and then enter in their desired weights?
Yes.
Is that okay?
Yes, you're exactly right. And it would be a drop-down selection or a button or radio button selection. Make it really easy for somebody to do this. Because like I said, I did it with PowerPoint and Excel and a lot of hopes to make it work. And in the end, ultimately, I think if we had to build the airbase that we were planning for crisis response, crisis management, I think it would have worked. But there's a lot of growing pains, both for me as a new guy, and I think for all the senior guys that I worked with as well, because they had never done it either. So the experience wasn't there, if that makes sense. That they should have been experienced, but they didn't have it. That they were never in this field, in the airfield at least. They built ground bases, but they've never built one suitable for airfields. So it was an interesting learning curve, and that's why I'd like to have some sort of custom application where I could teach, 6 times a year at the engineer training house or schoolhouse, how to do this, how to run the program, and that's it. And I think that would really help.
Gotcha. Looks like you have one more suggestion from Matt in the chat
Okay.
box.
Maybe consider ArcGIS Experience Builder to build that custom application if your team has ArcGIS Online or ArcGIS Enterprise. Okay. I don't have Enterprise. So I'm doing this solely. This is just on my own through coursework. This actually, it sort of interacts with my professional life. But the government has no idea I'm doing this, that I'm working on this. It's just something from my own experience. I was thinking back, how can I apply what I've learned through the coursework of the masters, and airbase planning just keep coming up in my mind. But if I'm pretty sure I've got ArcGIS online, at least I can work that.
Yeah, you would certainly have your ArcGIS Online account through Penn State and access to Experience Builder as well.
Okay.
So those would be possibilities. Sure.
I'll have to check that out. I don't think I've looked at anything at Experience Builder yet.
Yeah, that would be for building something web based, a web app.
That's
You could
exactly,
also,
yeah,
yeah, there's
exactly what I'm
also
looking for.
building something on, as a custom tool in ArcGIS Pro would be another possibility.
Perfect.
All right. Well, thank you, Fred. Nice job and best of luck on completing your project. And that brings us to our next presentation that we're going to go back to a 596B presentation. Everardo Balboa is going to talk to us about a mobile application for use in the natural gas industry. Ever, are you ready?
Yes, sir. Can you all hear me?
Yes, I can hear you.
Let me just share this. Let me know if y'all can see my screen.
Not quite yet. Looks like it's coming now. There it is.
Well, good evening. My presentation is on the development of a mobile application as an aid to the gas industry land rights acquisition. My presentation outline would be this, who am I? Why is right-of-way acquisition important? I'm going to review the existing process at my workplace. I'm also going to talk about the execution of a mobile application and how I believe it will improve our current process. I'm going to do a live demo on the application as it's going to be used in the field. And also talk a little bit about the future use of the application. Who am I? My name is Everardo Balboa, and I am a right-of-way agent for Texas Gas Service, which is a division of One Gas out of Tulsa, Oklahoma. I have over 20 years experience in land acquisitions, engineering, urban planning, and as a GIS analyst as well. I have a passion for anything related to GIS, from mapping to application configurations for data collection. I see the potential to implement GIS applications to existing pipeline processes. Since that's what I work in natural gas pipeline, I see a lot of potential in implementing this type of applications there. Why is right-of-way acquisition important? Well, it helps us extend our network to keep up with demand in our service areas. It also protects against hazards. A right-of-way corridor, once we acquired it, it should remain clear of anything that blocks access to the area, either for maintenance or installation. It avoids project delays. The way it avoids project delays is if we have an exclusive right-of-way, no other utilities are there, so therefore we are able to work without any mishaps from any other company as well. The current process that we have in place as land agents with Texas Gas is we receive projects through a program called Dynamics. They'll send us a project location, which is usually normally a site map, Google Earth map or something of that nature. They'll provide us with an exhibit of land needs. This is actually prepared by designers or engineering consultants. Once we receive those documents, we'll go ahead and request a survey permission, which is a Texas law, from the landowner. We cannot just go into any property and start doing surveys. We still have to get verbal or written permission from him or her. Once a survey is done, once the verbal permission is done to conduct a survey, we'll go ahead and request a survey from an engineer or land surveyor, which usually takes about 2 to 4 weeks to complete. Once we have that survey done, then we have to request an appraisal, which sometimes takes up to a month to conduct. Once we receive the appraisal, then we send our first letter, initial offer, which, by the way, the landowner has 30 days to respond as well. We receive our projects through a program called Dynamics, which is our company goal is to receive the 100% of all land requirements through this particular program. Now, what is Dynamics? Dynamics is a program that helps businesses to organize and manage their data. It's also an ERP, which helps us run the entire cycle of the project. How do we use it? We use it to, as land agents, we use it to keep track of incoming land acquisitions itself. That is the portion that we use it for. The Dynamics interface, it starts with the project request from the engineer or customer development, which is our growth department. What they do is once they receive that project, they will create a Dynamics program that looks similar to what you're seeing on the screen. It's just the project name, gives it a work order number. And then they click from there if they need any right-of-way, private right-of-way acquisitions. Once the designer or the engineer presses that particular button, that right-of-way, permanent right-of-way is needed, there's an email that is triggered that is sent to every land agent associated with this project. The information in the Dynamics program is what you see, similar to what you see on the screen, is what's provided to us, which is document attached, which in this case would be a site map. And they'll just give us a couple of notes of what might be needed. The project design, this is something that's created by the either designer, in-house designer, or outside consultant, engineer consulting work. This particular case, the design is 100%, but was done without the right-of-way land acquisition agent's input. There was no field visit done or no meeting with the landowner. And I'll touch a little bit further down the presentation why all this is important. In the project itself, they also create the financials for the project itself. But again, the right-of-way cost was not included in this particular project itself. And the reason it's important is in order to make any changes in our industry, before we do any changes to the budget itself, it usually takes about a week, week and a half to do the whole cycles of getting the approvals. I will touch base on the application that I created that's going to benefit the budget and design as well. Once the acquisition is complete from our part, this particular program only has about 4 fields that we have to, as land agents, we have to populate, which is number of landowners, construction stipulations, number of tracts, and number of tracts obtained or required. Once we do that, then the project is therefore out of our hands and is ready for construction itself. It sounds simple enough, but there is some information that still needs to go into the project planning, which is budget, design as well, and also state requirements that we need to meet that are not being included in the current process. That is the current process that we have in place. I will now be discussing how the mobile application that I created can improve our current process by providing cost information for budget. It'll provide some information like landowner name, property ID that can assist in starting the research, deed information, cost per square foot. We can provide some information to the designer. If the designer has, if we go out there in the site visits, if there's any particular obstacles or recommendation from the landowner, we can do there on site, and we'll go ahead and send it to the designer. And I'll talk about it a little bit more during the presentation itself. It will also provide details to the landowner on our first meeting that we will be in compliance with House Bill 2730 that was passed in Texas in January 1st of 2022. How was the right-of-way mobile application created? We analyzed the current process. Well, I analyzed the current process. I researched other utility companies and transportation agencies on their right-of-way acquisition process. I researched some pros and cons of using mobile applications. I met with internal and external stakeholders that are involved in the project design and estimating. I configured the ArcGIS field maps application to capture the data that is necessary for budget design and House Bill 2730. And I presented the application to the designer, estimators, and our engineering, which is our operations group. The agencies that I researched, the transportation agencies and other utility companies, were Atmos Energy, which is out of Austin, Texas, and Kinder Morgan out of Houston. The transportation agencies was the Texas Department of Transportation, Minnesota Transportation, and Illinois Department of Transportation as well. What I've found out during my literature review was that none of these agencies use a mobile application to capture any right-of-way information. Their existing right-of-way programs consist of digitizing georeference, or they converted CAD files into GIS layers. All they're doing is just drawing and adding some information of existing acquisitions that they've done. And whenever a new one comes in, they'll just go ahead and draw it up. But they're not capturing any additional information out in the field. The pros and cons of using the application is the data capture, real-time information. It'll provide location of the area, collaboration among departments, and it'll help with better decision-making. The cons is not everyone can use them. Not everyone can use the mobile application. In this case, we would need additional training for new users. Mobile equipment might not be equipped to install applications itself and to update and the maintenance of it. Security, when I talk about security, that's security within my workplace, security with our IT department, our industry, and especially the company I work for, I can only speak for them, is they're very stringent when it comes to allowing any external data being uploaded into our servers or anybody having any access to it. When I met with the internal and external, which is our engineering department and operations, our real estate department, that's the land agents, and our subcontractors, which are right-of-way agents. When I met with them, they liked the idea of creating this application because of the information that we believe can improve in our design and our cost, and to avoid project overruns. The benefits of using the mobile application is the automatic data capture for budgeting purpose. What you see on the screen is field maps of the application that got created. The red outlines that you see, those are manually populated, and the blue boxes that you see there, those were created by an arcade script to automatically populate the cost. The price per square foot is extracted from a base application, which is a base layer, which has name, property ID, and price per square foot. Let me rephrase. Let me go back a little bit. The red is the one automatically captured along with the price per square foot. Project name, length, and width, those are manually entered. Now, House Bill 2730, that went into effect January 1st of 2022. What that means is that we need to provide information to the landowner on the number of pipelines that may be installed on his property. we need to provide description of appurtenances of or pipelines of what is it that we're trying to install or we're trying to build in there. The maximum diameter of each pipeline to be installed. The commodity that we're going to use, either natural gas, crude oil, petroleum products such as motor gasoline, diesel, or oil. Since I'm in the natural gas industry, I can tell you all that it's just going to be natural gas in this case. Also, if it's going to be exclusive or non-exclusive. These are requirements that we have to provide the landowner as per the House Bill 2730. During our initial meeting, we can have in the mobile application, we can have this type of data, this type of information already populated, or we can populate it once with our initial meeting with the landowner. We can also make any modifications that need to be done. For example, the number of pipelines, we can say 2. The landowner can say we're willing to negotiate only 1. And this type of the diameter of what is it that they're willing, if they don't want like a big pipeline in there, 12, 24 inch, maybe they want a 4 inch. Exclusive rights or surface rights. All this data is going to be captured in real time. And all this data is important to capture because any changes to the scope of the work, it's a change in cost and change in time for any project that we have in the books. Now, why I chose field maps? Because of the map view. This is just an example. Our service area covers Texas, Oklahoma, part of Texas, Oklahoma, and Kansas. So for this, for my project, I only concentrated in specific city in South Texas. But the idea is to implement all this all across our service areas. Now, the important is because of the map view, we're going to use the parcel data as a main map. The map markup, the freehand sketch, they create a new layer. That is what I did and actually extracted information from this base layer, which, as I said before, it captured the name, the landowner name, property ID, cost per square foot. And it also captures information on populate information that we put in manually in there that the designer and operations group can easily access and make the decisions there if changing route or we proceed with what we have. I also like the measuring tool, the search. We can search either by property ID or by, if we go to the new layer that was created in the free sketch, we can do by project name, or we can do by cost itself. Direction, the compass is very important because some agents are not familiar with specific areas that we are working in, or construction crews are not familiar with when I say construction crews, I mean subcontractors that we hire to do this job. Some of them might not be very familiar with the areas of where they're going to be working. And if we provide this information to them, they can navigate to it. The offline capabilities by creating those the mobile application packages, and the place markers, which they would help me identify obstacles on the field that we can populate in the new layer, and again, send it over to the designer and the engineering group in real time. Now, I'm gonna show a live demo if that's all right with you all, of how this is gonna work. Can you all see my screen?
I'm only seeing your PowerPoint window right now.
Okay, let's see. How can I? Only the PowerPoint.
There we go.
Okay. This, what you see in the screen is the field map application. This is the idea is to provide all this information again and data captured right away cost that's going to give me a low, medium, and high range to do negotiations with the landowner itself. But this is, let me show you an of what is it that I'm talking about when it comes to extracting information. I'm just going to do something very quick here. See, this one, it extracted the name of the landowner, the property ID, and it extracted the price per square foot, which is $4. I'm not sure if y'all can see it. Let me just move it a little bit further up. Okay. The idea of the application is once we do 200, no, length 200 by 25, it automatically populates the easement value, the acquisition value, which was this is the low limit, the medium, and the high. The reason I added the medium and high, the 25 and 50%, is because it is part of our current process when we do land acquisitions to do a low, a medium, and a high. We can go up to 50% of the estimated cost for the acquisition. Survey permission. This is what the field technician or the land agent is going to be able to do out in the field. Survey permission, we can talk to the landowner. If he or she tells us yes, then we can populate yes. No temporary. This is what the landowner sometimes requires, especially if it's up in farmland. Sometimes they're required to be 6 feet. Product type, we'll put natural gas. Number of pipelines, we'll do 1. Pipe diameter, we'll do 8-inch. Exclusive rights, yes. Surface rights, no, because there's nothing going to be on there. Notes, just start 1/1/24. And this information, once it's completed out in the field, it will save it on a map, on a web map that we're gonna have access to, which is just the group of engineering, operations, external stakeholders, and real estate. I am currently working with our security team, our IT, to see what we can do to go ahead and implement this particular application into the existing mapping that we have. We also talked about doing the future use. Once the future use of the application, our integrity management engineering really like the idea that we can configure the application to extract information from existing pipeline layers to do an inspection report that is mandatory by state and federal agencies for our record keeping itself. Some data will be manually implemented, manually entered. Some of them would be extracted automatically. In this case, soil information can be extracted automatically. Segment number, line number, all that data associated with a specific geodatabase or a shapefile, we can extract it. I mentioned that this application was going to assist us with the project design for budget as well. The project design, for the project design is if the application we completed on site and we see no obstacles, we can populate this information, send it, and that would be okay. We can proceed with that particular alignment. But if we find any other obstacles, for example, additional utilities that are already installed, landowners sometimes they build a storage shed like within a week, and if they're there, then we can automatically provide that information to the designer where we can do a reroute itself. For the budget itself, we can provide this type of information of the actual cost of the acquisitions, which can be included in the budget portion of the program, which therefore we will no longer have to wait that week to week and a half so that we can do any amendments to it itself. So I believe that providing this information, it'll help us expedite the project itself without any project delays. There are exceptions, of course. Sometimes the landowner, for one reason or another, they don't want to sell. Then we got to look at alternative routes or alternative means of acquiring that particular right of way, either through condemnation proceedings or additional monies itself. But with this information, operations would already have that on hand and they can make the better decisions. And with that, I conclude my presentation, and any questions or suggestions?
All right, nicely done, Ever. Thank you.
Yes, sir.
Looks like you've got a question from Ryan in the chat box.
Oh, Ryan, might have use in other industries as well. Have you thought about expanding it for use in other utility applications? I've talked to, again, my experience is that with urban planning, city planning, I've only mentioned this unofficially meeting with the Public Works Department for a city down where I live, down in South Texas. And we were discussing about using some sort of application like this for their record keeping as well, for any mains, sewer taps, maintenance facilities, and anything that they have. So to answer your question, yes, I've looked into other utilities. In this case would be public work, water lines, and sewer lines.
Other questions for Ever? While we wait to see if anyone else has a question, I'll ask one, I suppose.
Yes, sir.
I think you obviously there's benefits to your app. Can you kind of reiterate, how much time are you saving by implementing this sort of solution, versus what you've been doing up to this point? You're more of a paper-based
yes, sir.
process.
It can save up to 2 to 3 weeks in the project, in the current process that we have. It can do that by providing this information off the bat, and right away, land agents like myself being involved in the design itself. If we can be involved since the very beginning of the project, not only by an email notifying us, let's go ahead and do land acquisitions, but us being part of the whole process itself, we can easily eliminate about 2.5 weeks. And the reason I say that is because taking a design takes some time, especially with we outsource a lot of the work. It's outsourced to engineering groups. And if we send a project right now and they come back and say within a week, week and a half, they'll give me a paperwork like, here you go. And I go out to the field and then I see all these particular obstacles, then I gotta make sure that I send them back to the designer, which is there's another week and a half to make those changes. So if we can capture that information off the bat, then the design, we shouldn't be making any changes to any design. So that's already
Gotcha.
a week and a half. Budget itself, if we can once the project is done in Dynamics, any changes to that particular project, any scope, in other words, cost, would have to go through a process of approvals to change of why and explanations of why the cost changed. So if we can provide at least some information saying, hey, this particular project is going to cost us $35,000 to acquire, that's the high end. We can budget $35,000, even though the project can cost us maybe $23,000. So therefore, we don't have to go through the process of changing that particular segment of the workflow, which is the budgeting purpose. So to answer your questions, about 2 weeks, 2 to 3 weeks savings.
Great, great. Any last questions for Ever? Looks like Fritz has one.
Okay. Relying on the existing parcel maps, how often you're relying? Yes, that's correct. Relying on existing parcel maps. How often do you notice boundary survey issues with the? That one was that particular question, sir, was taken into consideration when I developed this tool. So that's why the boundary, the actual limits of the acquisition are manually entered. If I go in there, I can draw a polygon, but I already have an idea of what is the length and width that we're needing. Because if I were to rely on the boundary for automatic calculations of the area, I might run into an error where the boundaries are not drawn correctly, and therefore the estimates are going to be off as well. Yes, sir.
Yeah, and that helps explain why when you did the demo there, you weren't too concerned that you were taking
Correct.
about 90% of that person's parcel.
Yes, sir. Yes. No, though this is only for the mapping purpose. We can always fix that in the web map. We can always just draw it nice to have it in our parcel. But the information that is captured is what's making the application very useful to our current process.
Right, right. Okay, well, thanks, Ever. Nice job. Congrats on wrapping this up. I know that you've already presented this internally a bit and gotten
Yes,
some very good feedback. So I hope to see this this proof of concept get actually implemented into your workplace.
Yes, sir. I sure appreciate it. And I want to thank everybody for giving me the time, and also my advisor, Mr. Detweiler, Professor Detweiler. He was very, very helpful throughout this whole process. Thank you, sir.
Thank you. Thank you. All right. And that brings us to our final presentation for tonight. We're going to go back to a 596A presentation. Lisa Giris, is that right?
That's correct. Yep.
Cool. Good. Lisa's going to talk to us about using deep learning to estimate population counts of wild horses.
All right. Can y'all see my screen?
Yes, I can.
Okay, perfect. So, hi everyone. My name is Lisa Giris. My advisor for 596A has been Karen Scheckman, and welcome to my capstone proposal presentation, where I'll be discussing a possible application of deep learning to conduct population censuses on wild horses. So to start with some high-level background, there are wild horses all over the United States. Most people are aware of wild horses living in the western US, but they can be found along the East Coast as well. These different herds are subject to very different management styles by various land management agencies. Most of the herds in the West are managed by the Bureau of Land Management and a few by the Forest Service. On the East Coast, many of the herds are managed by the National Park Service, save for a few that are managed by private organizations. I've been working in wild horse management for most of my professional career, so I hope to make that interest the focus of my capstone project. And to get into some more detail about the different herds, I'll start with the Western US. The BLM manages herds according to what herd management area, or HMA, they live in. These are geographical areas of public land in which the horses are free roaming, yet according to the mission of the Bureau of Land Management, these HMAs may also be used for other purposes, such as resource extraction and commercial grazing. The BLM calculates an appropriate management level, or AML, based on the carrying capacity of the range after conducting vegetation and water surveys. The AML is a population range that's considered ideal for maintaining genetic diversity among the herd while not subjecting rangelands to overgrazing and erosion. Since many HMAs have no natural predators of wild horses, or those natural predators have been eradicated, their population has generally grown unchecked. Several methods of population control are used by the BLM in attempt to manage the wild horses. The first being a non-hormonal birth control, also referred to as immunocontraception, which is usually administered via a dart rifle. This method is very effective, but getting close enough to horses to administer that immunocontraception is not always feasible. Another strategy the BLM uses to round up the horses in what is known as gathers, either using a helicopter or with bait traps like food or water traps, and putting the number of horses in excess of AML up for adoption. This method is especially controversial among the general public, as gathers can be stressful and even traumatic to the horses, and finding competent owners to adopt them is also difficult. So as I mentioned before, it can be difficult to get close enough to some herds to administer immune or afraid of other people and out of the extremely difficult in the exact remote the ability to make informed management decisions. Wild horses can also be found on the East Coast, mainly on barrier islands such as Assateague Island in Maryland and Virginia. Tourist destination popularized by Margaret Henry's book series Misty of Chincoteague, as well as several locations along North Carolina's Outer Banks, and even as far south as Cumberland Island near the Florida-Georgia border. Since many of these places are popular tourist destinations, most of these herds are very habituated to people. Management practices are also very different. Horses are not rounded up and adopted out, and immunocontraception is much more easily administered to these habituated horses. Additionally, it is much easier to know the exact population of these herds simply by conducting regular field surveys. I mentioned field surveys. There are a few methods used in conducting population censuses on horses. Field surveys entail actually getting out into the field, out on the range or HMA, and counting the horses that you see in front of you. This is generally done every few months where possible. Aerial surveys are generally used for more remote herds. This entails a pair of surveyors going up in a small plane and zigzagging over an HMA and counting the horses seen below. Obviously, this method is much more difficult, requires a trained eye, and does not result in as much confidence as a field survey of a habituated herd. I did also find one study in my literature review with kind of an experimental method of using infrared imagery in hopes that the horses would stand out, which had varying success. So to attempt to answer this question of how to ascertain the population of these more remote herds, I'd like to develop a deep learning model trained with very high resolution imagery that can identify and count wild horses. My idea is to train and test the model using imagery of locations where the horses are easy to find and where the exact population is known in order to QC the accuracy of the model. So in theory, the output would be a pre-trained model that could then be applied to imagery from remote Western herds where the population estimates have a low confidence as a means to better ascertain what those population counts may be. So with that being said, these are my two areas of interest, Shackleford Banks in North Carolina and Assateague Island in Maryland. I've lived and worked at both of these places and specifically worked with both populations of wild horses that live on these islands. This does give me some advantage in training the model, as I know places to look on each of these islands where horses tend to be found. Additionally, both of these herds are quite habituated to people, and field surveys are regularly conducted by National Park Service biologists. So the exact populations of horses on each of these islands is known and shared with the public. Therefore, I could compare the final results of my deep learning model to the population of horses on each island from the year that imagery was taken. Sourcing imagery was one of the biggest obstacles for me this semester. As it turns out, finding super high resolution imagery that is free and easily obtainable, as well as a fine enough resolution to identify horses, is pretty difficult to find. I initially set out to focus on Western herds, but found that there was little to no imagery of those areas available. So I had more success finding imagery that overlapped areas where East Coast herds lived, which led me to use these locations for training my model. So here are some examples of imagery I found in my search for data, with all three examples showing the same view of an area of Assateague Island. Starting from the left, I have the most recent NAPE imagery with a resolution of 60 centimeters. For context, this extent shows a group campsite area, so we're looking at tents and some shade structures here. However, they're quite blurry and it's hard to make out what these objects are if I didn't already know, and I certainly wouldn't be able to identify a horse in this imagery. In the middle, I have 30 centimeter imagery from the National Geodetic Survey. This imagery is a lot better, though in my opinion, still not fine enough to identify a wild horse. This imagery is from the wintertime, so there's no campsites here to look at, but the picnic tables here are still a little blurry. And then finally, on the right is imagery I'll be using, which is 4 centimeter imagery from the Army Corps of Engineers, and this imagery is available for much of the East Coast, and obviously 4 centimeters, very high resolution. So here's some examples of some horses that you can see in the 4 centimeter imagery at a couple different extents. The very high resolution of this imagery allows me to identify horses with very high confidence. The only downside to this is the file size. The imagery, which I've downloaded from NOAA's data access viewer, amounts to several hundred gigabytes for my areas of interest, which takes a long time to download and a long time to add to a mosaic in ArcGIS Pro. To get back to deep learning has a huge variety of applications, such as feature extraction, point cloud classification, even image redaction. Esri holds a collection of pre-trained deep learning models tailored to specific tasks that are free to download and run on any compatible imagery. So this is a screenshot of a few of the pre-trained models available on the ArcGIS website. Got things like pool detection, ship detection, tree detection, and so on. There's dozens more than what's seen here with applications like blurring out faces or license plates and imagery to things like land cover classification. So definitely check that out if y'all are interested in learning more. And I came across these pre-trained models during my literature review, where there existed some for other wildlife species, such as the elephants you see in this slide, as well as Arctic seal detection and shorebird detection. All of these examples use imagery with a similar resolution to what I'm using, generally around 5 centimeters. Once you download a model, you add it to your project and customize the parameters seen on the right to work with your own imagery. Adjusting the threshold, for example, I'll change the confidence score above which detected features are included in the results. Things like the batch size you can change based on capabilities of your graphics card. I'm not using a pre-trained model for my project, but reading through the development processes and use cases of the wildlife specific models that I found have been helpful in working through creating my own model. Since I'm building mine from scratch, I have to generate my own training samples myself. So what that entails is finding horses in the imagery and drawing a polygon around every single one. The more training samples you have, the better your model understands what you're looking for. I'm hoping to locate at least 100 horses between Assateague and Shackelford so that my model is successful. Assateague has about 80 horses. Shackelford Banks has about 120. I'm hopeful that between these two areas of interest, I should be able to find that many horses. However, the 2017 US ACE imagery that I'm using is available for much of the East Coast, so I could always go back and download more for some other areas where horses can be found, should I find myself in need of more training samples. And here's my tentative timeline for completing the project. I will be taking 596B in the spring 1 term, so these dates reflect the dates of that session. I would like to complete acquiring and pre-processing imagery prior to the start of the spring 1 term so that I'm ready to hit the ground running once classes start. Pre-processing entails loading the imagery into Pro, combining each tile into a mosaic and letting Pro build pyramids for each of those tiles. Obviously, this is one of the most time-consuming steps since the files are so large, which is why I'd like to have it out of the way as soon as possible, so I have more time to work on training and fine-tuning the model. I'd ideally like the model to be completed on or before February 28th, which then gives me 2 weeks to finalize my final paper and presentation before the end of the term on March 13th. So to summarize, my anticipated results for this project would be a successfully trained deep learning model that identifies wild horses in very high resolution imagery with a high confidence interval. This model can then be shared and applied to high resolution imagery of other wild horse areas or HMAs where population numbers are uncertain in order to provide better data for rangeland management decisions. And that's it for my presentation. I'll turn it back over to y'all in case anyone has any questions. Thank you.
All right, thank you, Lisa. Nice job. Looks like you've got a question from Ryan Baxter in the chat already.
Sure. So if there happen to be other animals, livestock, deer, etc., in the imagery you use, how might your model be able to differentiate them from the horses you're interested in? That's a great question. Yeah, so specifically on Assateague, there are some other species of similar animals, deer, and like the type of miniature elk species is there as well. I'm hoping that with sufficient training samples, the model won't have any confusion between horses and other species of wildlife. Based in some of the other pre-trained models that I investigated, like the elephant identification, I'm sure there's other animals besides elephants in their study area. And honestly, I don't really recall them touching on differentiating between species. So that definitely is something to keep in mind as I'm working through the model. Hopefully it's not misidentifying deer as horses, but that's a great question. I think the solution to that would probably just to add more training samples.
I have a question. I
Sure.
saw in your slide when you were delineating the horses as part of the training that all of your shapes were rectangles. Are you limited to rectangles, or can you do irregular shapes?
No, you could do like a freeform shape. Especially like I've seen with tree detection, usually they'll do a circle. With the elephants, they did do a rectangle as well. But yeah, I mean, I could do like a freeform polygon as
Yeah.
well if I wanted to draw like super closely around the horses.
Yeah, I don't know how much difference it would make. If it doesn't make much difference, then probably is not worth the effort, right? But that was just a thought that came to mind. Ryan's got another question for you.
Sure. I mentioned that data storage is very large. Might it be possible to store this imagery in the cloud and process it there rather than download it? That's a good question. I don't personally have like a cloud storage. I think that I have access to where I could be like remotely processing the imagery. My solution thus far has just been to do like batch processing, so I'm not like running the whole model on the entire island. But yeah, I mean, I'm also storing the imagery on an external hard drive because I simply do not have that much room on my laptop. But yeah.
Yeah, this is Karen. I'll jump in there a little bit too. So, most of these deep learning models with high resolution imagery are very computationally intensive. And not only that, they require a lot of, they use graphics memory. So ultimately to do it over large areas requires machines that, we don't have on our desktops. But again, we don't really have access to that kind of platform, and getting the imagery, finding the appropriate imagery in the cloud already is another bit of a problem. So like in my 589 seminar this semester, we used Google Earth Engine and Microsoft Planetary Computer, and you can do this kind of deep learning on those platforms, and that ultimately might be a better way to do it because you can set up a virtual machine with a lot of memory. but all this imagery isn't necessarily up there and it's not easy to get access to it. So yeah, for the time being, and for prototyping it and just figuring out, training the model and all that, I don't really think we have too many alternatives than to just try to work it out in a desktop and then see if we can scale it up at some point. If that makes sense.
Yeah, I had a similar question to Ryan. And I'm certainly no expert on this topic, but I was similarly thinking that you could potentially put the data up in the cloud, say on Amazon Web Services, and then I forget the name of the technology that's used, but basically you can ask a virtual machine to split your task up across several servers and have them all working on the data at the same time. And as a way of speeding up the processing.
Well, right. And then now Esri has ArcGIS Pro for Microsoft Planetary Computer, similar thing, only it's in the Azure cloud instead of the Amazon cloud. But you're paying for an account, you're paying for the, all of the, basically you pay for the Azure account and the time on the virtual computer.
Yeah, there's certainly costs involved, both money and
Right.
There's a learning curve involved too, which takes a lot of time, which you may not necessarily want to expend. So yeah.
Right.
Okay. Good.
But ultimately, I think that is all this kind of deep learning on high resolution imagery. It does need to take place in some kind of a cloud server environment. It's not really a desktop application for sure, but at least to kind of prototype on a small amount of imagery, it's probably a more reasonable way to try to get something accomplished.
Right. Are there other questions for Lisa? Well, I will just ask folks in 596A again to please provide some feedback to Lisa through the peer review form. I put the link up a little while ago. And yeah, well, that's going to wrap it up for tonight. As always, we had a great set of engaging talks across a range of topics. Thanks to everyone for coming tonight and asking questions and enjoying these talks. Best of luck to the 596A students on completing your work, finishing your degrees. And again, congrats to the 596B students, at least on getting your presentations done. You might still have your papers to finish off, but great work, everyone, and have a good night.